Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic solid state. In that we will study imperfections in the solids. This is a portion from class 12 of CBSE. Now see students, any irregularity in the pattern of crystal arrangement in a solid lattice is called imperfection in solids. The occurrence of defects takes place when the crystallization occurs at a very fast or intermediate rate, because the particles don't get enough time to arrange themselves in a regular pattern. Because if the particles are to arrange, some time is required. If that time is not available, we will get the imperfections. The properties of the materials are profoundly influenced by the presence of imperfections. So we find that the crystals are not perfect. And also a solid consists of an aggregate of large number of small crystals. And just now we have seen that the crystals have certain defects. And this usually happens when the crystallization process occurs at a fast or moderate rate. Now because of these imperfections we will see some defects. First of all, we study that the defects are of two types. One is point defects and line defects. Let us see one by one. The point defects are the irregularities from ideal arrangement around a point or an atom in a crystalline substance. So in a crystalline substance, when there are irregularities from the ideal arrangement around an atom, it will be point defect. And if the irregularities from ideal arrangement are in some rows of lattice points, then there will be line defect in the rows of lattice points. That gives rise to line defects. First we will concentrate on point defects. So we will see types of point defects. First we see stoichiometric defects. Now these are point defects which do not disturb the stoichiometry of the solid. Stoichiometry is not disturbed, and we also can call them intrinsic or thermodynamic defects. They are called intrinsic or thermodynamic defects. So first we see stoichiometric defects. In that, first is the vacancy defect. Now when some of the lattice sites are vacant, the crystal is said to have vacancy defect. There is vacancy in some of the lattice sites. Since there is some vacancy, it will result in the decrease in density of the substance. There will be a decrease in the density of the substance. Now see, in this figure you see, so there is a point defect in this solid. When an atom is missing from one of the lattice points, you see here, these are the vacancies. So atom is missing from one of the lattice points. Next comes interstitial defect. When some constituent particles occupy an interstitial site, the crystal is said to have interstitial defect. Okay, the constituent particles occupy an interstitial site. Here you see, these are regular arrangements here, but here you find interstitial space is getting occupied. So this is a defect. The vacancy and interstitial defects can be shown by non-ionic solids, because in case of ionic solids there must be electrical neutrality. Ionic solids must maintain electrical neutrality. Now we see another defect, Frenkel defect. Now this defect can be shown by ionic solids which are having ions. Now see, we have two types of ions, anion and cation. The anion has negative charge The cation is positively charged. Now in this case, in Frenkel defect, the smaller ion is dislocated from its normal site to an interstitial site. Okay, it is dislocated from its normal site to an interstitial site. So there will be a vacancy defect at the original site and interstitial defect at the new location. So vacancy defect at original site, you see here, there is a vacancy here. There is no ion, so there is a vacancy defect at the original site, and it has come here, additional, this area. Here you see, this is interstitial defect at its new location. Now, Frenkel defects are exhibited in ionic solids with a large size difference between anion and cation. When the cation is usually smaller due to an increased effective nuclear charge. Cations are positively charged and they will be smaller. Cations are usually smaller due to an increased effective nuclear charge. Some solids which exhibit Frenkel defect are zinc sulfide, silver chloride. Next comes Schottky defect. It is a vacancy defect in ionic solids. Here again it is ionic solid. It is a vacancy defect, means some vacancies will be there, but to maintain the electrical neutrality, the number of missing anions and cations are equal. We know that anions are negatively charged and cations are positively charged. So how many anions or cations are missing? It is in such a way that they are equal. The charge is balanced, means total charge of anions which are missing will be equal to total charge of cations which are missing, so that electrical neutrality is maintained. And since it is a vacancy defect, it decreases the density of the substance. It decreases the density of the substance. Now this is the diagram you see. Here negative, positive, negative. So here in this site one positive ion is missing, and here one negative ion is missing. So charge will be balanced. In the same way below you see, after positive, here one negative ion is missing, whereas here one positive ion is missing. So overall here two positive ions and two negative ions are missing, which will maintain the electrical neutrality. Schottky defect is shown by ionic substances in which the cation and anion are of almost similar sizes. For example, NaCl. So I hope students you all could understand the topic which I discussed today.